y'all, it's Miss Flores. So today we are going to be talking about prime factorization. So yesterday we learned about prime numbers, right? Prime and composite numbers. The day before we learned about factors. Remember, factors are numbers that multiply to get the answer, so we get a product, right? So factors are numbers that can multiply together to get another number, right? So now we're going to learn about prime factorization, which is basically where I'm splitting up a number into a multiplication problem of just prime numbers. So when you're asked to find the prime factors of a number, you're trying to find all of the prime numbers that can be multiplied together to create that number. So the way that we do that is, let's look at 12. So the way that we would do this is I would take 12 and I'm going to split it into a multiplication problem. So I have to think about, okay, what two numbers can I multiply to get 12? So well, let's say that I know that 2 times 6 get 12, right? 2 times 6 is definitely 12. Well, I'm going to keep breaking up these numbers until I only have prime numbers left. What I do is I circle all of my prime numbers. So 2 is a prime number, right? I can't split that up into another multiplication problem because it would still end up just being 2. So I'm going to circle it to know that I stopped there. Well, 6 is not a prime number, so I'm going to split it up into a multiplication problem. So what times what is 6? Well, 2 times 3 is 6, right? 2 is a prime number and 3 is a prime number, so my prime factorization would be my prime numbers multiplied together. So I had 2 times my other 2 times 3. So my prime factorization would be 2 times 2 is 3. Now, let's say that you started off with a different multiplication problem. Let's say that instead of you saying 2 times 6 was 12, let's say that you started off with 3 times 4 being 12. Well, 3 is a prime number, so I can't do anything with it. I'm going to circle it to know that I stopped there. Well, 4 can be split up into a multiplication problem of 2 times 2. So I still have both of those as prime numbers. My prime factorization is going to stay the same, right? I have 2 2's and 1 3. So I'm still left with 2 times 2 times 3. So no matter how you start off with it, if your math facts are correct, if your multiplication is correct, you will always end up with the same answer no matter how you start off. Let's look at the next one. So now I've got 30. So remember, you can start off however you want. Well, I know that 3 times 10 is 30. I also know that 2 times 15 is 30. I also know that 5 times 6 is 30. So no matter which way you start off, it should always get the same answer. So I'm going to say that 30 is equal to 3 times 10. Right? Well, 3 is a prime number, so I can't split it up into a multiplication problem. So I'm going to circle it so I know that I stopped there. So now, 10, what multiplies to get me 10? I know that 2 times 5 gets me 10, right? 2 is a prime number, and 5 is a prime number. So now I'm only left with prime numbers, so that would be my multiplication problem. That would be my prime factorization. So I would have 3 times 2 times 5. And you can always double check your work, right? Because you can just do the multiplication to solve it. And if you end up with your same number that you started off with, you know it's correct. So 3 times 2 is 6. 6 times 5 is 30. So I know it's correct. And just like we did before, we could always start it off differently, right? We could say, let's say we decided to say that 5 times 6 was 30, right? Well, 5 is prime, so it stops there. But 6 is 2 times 3, right? 2 and 3 were both prime. I'm still left with the same answers, right? I have 1 5, 1 2, 1 3. I am good to go. Let's look at another one. Let's say we've got 25. Well, 25 is 1 times 25, right? You never want to start off with a 1 times 25, right? Because 1s don't really belong in prime factorization because 1 is not technically a prime number or a composite number because it only has one factor. So we don't want to do any of the 1 times anything. We always want to start off with, other numbers. So I know that 5 times 5 is 25, right? Well, 5 is a prime number. So I circled both of them, and I'm done. Problems like this are going to be pretty fast. So my prime factorization would just be 5 times 5. All right, let's talk about 81. So 81, I know from my math facts that 81 is equal to 9 times 9. 9 is not a prime number, right? Because it can be divided by more numbers than just 9 and 1, right? To get 9, I can multiply 3 times 3. 3 is a prime number, though, so I'm going to circle both of my 3's. So now my other 9, like we said, 9 was equal to 3 times 3. So I end up with 3 times 3. I circle my 3's, and I'm left with just 3's as my prime factorization. So it would be 3 times 3 times 3 times 3. And I don't know if I've mentioned this yet, but what we are creating is we're creating something called factor trees. If you notice, this kind of looks like a tree, right? It's kind of shaped like a Christmas tree, which is why they're called factor trees. So in order to find the prime factorization, which was my 3 times 3 times 3 times 3, I create factor trees. Some of them look more like trees like this. Others, might be kind of lopsided like how we did here for 12. But they are all called factor trees. All right, let's look at 44. So 44, if I were to look at like a multiplication chart, I could see that 4 times 11 is 44, right? 11 is a prime number, so I'm going to circle it so I stop there. But 4 is not prime. 4 is equal to 2 times 2. 2 is a prime number. So now I've got all prime numbers, so my prime factorization would be equal to 2 times 2 times 11. You can double check your work by multiplying your numbers back together. 2 times 2 is 4. 4 times 11 is 44. All right, let's look at one more before we get to our assignment. So let's look at 36. 36, there's a couple different ways I can do 36, right? I could do 4 times 9. I could do 6 times 6. I could do 18 times 2. Let's start off with 6 times 6. Well, 6 times 6 is 36, right? 6 is not a prime number. 6 is equal to 2 times 3. 2 and 3 are prime numbers, right? So I'm going to stop there. So now let's do the other 6. 6, again, is equal to 2 times 3. 2 and 3 are both prime numbers. So my problem is equal to 2 times 3 times 2 times 3. If we were to do this another way, right? So instead of doing 6 times 6, we could have done 4 times 9. Neither 4 or 9 are prime numbers, right? So I got to split them up again. 4 is equal to 2 times 2. 2 is a prime number. So I stop there. 9 is equal to 3 times 3. 3 is a prime number, so I'm going to stop there. So just like we had before, it might be in a different order. I might write it as 2 times 2 times 3 times 3 now. But I'm still left with 2 2's, right? I've got two of my 2's there, and 2 3's. So I'm still left with the same answer. And you can double check your work by multiplying along. 2 times 3 is 6. 6 times 2 is 12. 12 times 3 is 36.
All right, y'all, let's look at today's assignment. So we're going to be filling in the blank on some factor trees on quite a few Google slides. So my first slide is always going to be the secret code of today's video lesson. We will tell the secret code here in a bit. All right, let's look at our first problem. So our directions are to find the prime factors by dragging the number tiles to the correct boxes, then type the expression below. So if you notice, I've got my first number that I'm doing is 12, right? I'm finding the prime factorization of 12. But I've got this blue box that's already filled in. If you look through your problems, you've got a couple boxes already started. As we keep going, there might be boxes already filled in. So what they do as well is they're kind of color-coded. So let's do this and I'll explain the color coding. So start off with 12. It says that 2 times something is 12. Well, I know that 6 times 2 is 12, so I'm going to drag my 6 to that box right there. Now, 2 is prime, which is why it is blue. In my problem, in my factor tree, the blue numbers that I'm going to have are going to be my prime factors. So not 12. 12 is what I start off with, but my numbers in the problem that I end up with that are blue, those are my prime factors, which is why only prime numbers up here are in blue. The rest are in black. So 2 times 6 was 12. So now, what about 6? I've got to split 6 up. Well, I know that 2 times 3 is 6, right? So now I'm done. So now I'm going to type my expression. Remember, my expression is all of my prime factors multiplied together. So I end up with 2 times 2 times 3 as my final expression. My prime factors, 2 times 2 times 3. All right, let's look at the next one. So now I've got 16. I'm wanting to split 16 into my prime factors. So my first step is to figure out what is multiplied to get 16. Well, they said that 2 times something was 16, right? I know that 2 times 8 is 16, right? So 2 times 8 is definitely 16. Now, 8 is not prime, so that means something, 2 times something has to be 8. Well, I know 2 times 4 is 8. 4 is not prime, so 4 has got to be split up into a multiplication problem. I know that 2 times 2 is 4. So now I'm done all my prime factorization, so now I've got to find my actual expression. So I'm going to multiply all my prime numbers together. So that would be 2, 2, 2, and 2. So that would be equal to 2 times 2 times 2 times 2. If you wanted to solve to double check, you could just multiply it all back together, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, which is what I started off with. All right, now we have 18. So 18 is being split up, right? 18 is not prime. They've split up into 2 times something is equal to 18. Well, I know that 2 times 9 is equal to 18, right? So 2 is prime, so it stops there. 9 is not prime, so I've got to split it up again. Well, what times what is 9? I know that 3 times 3 is 9. And I'm done. I'm left with only prime numbers. I've got 2, 3, and 3. So my prime factorization would be 2 times 3 times 3. Double check my work. I can multiply them back together. 2 times 3 is 6. 6 times 3 is 18. Well, look, we've got 18 again. But now, you notice, I'm not starting off with 2 times something. I'm starting off with 3 times something, right? So this is another way to solve for 18, but I should end up with the same expression if I'm doing it correctly. So 18 is split up in a multiplication problem, 3 times something. Well, I know 3 times 6 is 18, right? 3 times 6 is 18. 3 is a prime number, 6 is not. So let's split up 6 into our multiplication problem. What times what is 6? 2 times 3 is 6. And now I'm left with only prime numbers. So I have 3, 2, and 3. So I have 3 times 2 times 3 as my answer. 3 times 2 is 6, times 3 is 18. So even though we said 3 times 2 times 3, our other one was 2 times 3 times 3, it's still the exact same thing. The main thing with multiplication, because you can flip-flop numbers in multiplication problems and still end up with the same answer, the main thing is that we have the same number of 2's and 3's in our problem for it to be equivalent. Let's look at 20. So I'm starting off with 20. 20 is not prime, so I got to figure out how to multiply to get to 20. Well, they're saying something times 5 is 20. I know that 4 times 5 is 20, right? Well, 5 is a prime number. 4 is not prime. 4 is composite. So what times what is 4? 2 times 2 is 4, right? So now I'm left with only prime numbers, and so those are going to be my expression, my 2, 2, and 5. So my expression is going to be 2 times 2 times 5. I can multiply it back together to check my work. 2 times 2 is 4, times 5 is 20. All right, let's do 2 more. We'll do 3 more, actually. All right, so now I've got 24. My next 3 slides are going to all be 24, but they're going to be done differently, but I'm still going to end up with the same expression because I'm starting off with the same number, right? All equal numbers. So if I'm dealing with 24, I can do the prime factorization of 24 multiple ways, and I should end up with the same expression no matter how I solve it, as long as my multiplication is correct. All right, so 24 is started off by saying 2 times something is equal to 24. Well, I know that 2 times 12 is equal to 24, right? So 2 times 12 is equal to 24. 2 is prime, so it is done. 12 is not prime, though, so it's split up again. It says that 3 times something is 12. Well, I know that 3 times 4 is 12, right? So I'm going to put my 4 down here. 3 times 4 is equal to 12. Now, 4 is not prime either. So 4 needs to be split up into a multiplication problem. 4 is equal to 2 times 2. And now I am done. I'm left with all of my prime numbers. So all my prime numbers multiplied together will be my answer. So 2, 3, 2, 2. So that's 3 2s and 1 3. So it's going to be 2 times 3 times 2 times 2. So let's remember that to double check our work on slides 8 and 9 that I should end up with 3 2s and a 3, right? Because to double check my work, 2 times 3 is 6, times 2 is 12, times 2 is 24. All right. 8, we're still dealing with 24, right? But now instead of it saying 2 times something is 12, I'm now saying that 2 times 12 is 24. Now we're going to do 3 times something is 24. Well, 3 times what is 24? 3 times 8 is 24, right? 3 times 8 is 24. And if you need help on some of these problems, you can definitely use a multiplication chart, right? 3 times 8 is 24. 3 is prime, so I stop there. 8 is not prime, though. 8 can be multiplied, have 2 times 4, right, to be multiplied to 8. So 2 times 4 is equal to 8. 2 is prime, so I'm done with that. I'm not going to mess with it anymore. 4 is not prime, though. What times what is 4? 2 times 2 is 4. So I'm left with 3, 2, 2, and 2. Just like we did before. 1, 3, and 3 2s. So my expression could be written as 3 times 2 times 2 times 2. And it is still the exact same because I have the same number of 2s and the same number of 3s. All right, let's look at 9. 9 is split up into a different problem, and it looks a little bit different, right? It looks more tree-ish than the other ones did. So now, we have 24. So we already did 2 times 12 is 24. We did 3 times 8 is 24. Now we've got 4 times something is 24. Well, I know that 4 times 6 is 24, right? 4 times 6 is 24. Well, neither of those are prime, right? So we've got to multiply we've got to figure out what multiplication problem gets me to those numbers. So I know that 2 times 2 is 4, right? And for 6, I know that 2 times 3 is 6. So now I've got all my prime factors, and my expression is going to be the exact same as it was before. I've got my 3 2s and 1 3. So it's going to be 2 times 2 times 2 times 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So these are all the exact same. They are all equivalent. So no matter how you start, if you started off with 2 times 12, 3 times 8, 4 times 6, I still end up with the same expression. All of my expressions are equal to 24. So this is our assignment for today. We have done the first 1, 2, 3, 4, 5, 6, 7, 8 problems together. So make sure you fill in these problems as well. The remaining 16 are for you to do on your own, and they're all going to be filling in, filling in the prime factorization. Some numbers will get a little bit bigger, like 50. So you might need to be making t-charts in order to figure out different ways that you can multiply to get these numbers. So make sure that you are using a multiplication chart. Make sure you are showing your work. You might want to grab a sheet of paper and maybe make your factor trees along with the activity, whatever helps you out. If you have any questions, please feel free to, comment on the stream, comment on your assignment, ask for help, and we will go over some of these problems together when we meet back up later today. All right, y'all, have a good day. Bye.